So in this case, we're going to take some systems of inequalities and we're going to put like a real life kind of spin on them a little bit. So there's going to be a context. We're going to write inequalities. We're going to graph them. And we're going to find their solution. So in this case, Sue earns $5 per hour when she babysits, $10 per hour when she tutors. She can work no more than 15 hours a week, and she wants to earn at least $100. So why don't we say that we're going to let X then represent the number of hours that she can babysit. And let's let Y represent the number of hours that she can tutor. And we want to write two inequalities to represent this situation. See if you can write the two inequalities. So when it says she earns $5 per hour babysitting, I'm going to think of that as being 5x. And then $10 per hour when she tutors, plus 10y. And that's going to be the money one, because she earns $5 per hour for X hours babysitting, $10 per hour for Y hours tutoring. She wants to earn at least, let's underline, at least. At least means that much or more, so greater than or equal to $100 for the week. Then the next part is that she can work no more than 15 hours per week. So the total number of hours she works can be no more than. Here's another thing to underline. That no more than. That means you can't go above it. You have to be equal it or below it. So less than or equal to 15. So these are my two inequalities to represent this situation. Let's go and graph them. Ooh, but you know what I'm thinking? Before we graph them, can we put them in y equals form? That might be a good thing to do. Let's see. Let's move this one. We'll throw it over there for now. Let's subtract 5x from both sides. So we get 10y is greater than or equal to negative 5x plus 100. Let's divide by 10. So we're going to get y is greater than or equal to 5 over 10 reduces to 1/2. 100 divided by 10 is 10. So there's our first inequality that we're going to graph. The next one's a little easier to solve. Negative x plus 15. So for this one, our slope is negative 1. Our y-intercept is 15. For the one over here, our slope is negative 1/2, and our y-intercept is 10. Let's go graph those. So if I'm going to set up my axes a little bit, I noticed that my y-intercept went up to 15. So maybe what I'll do is I'll make sure that I go up to at least 15. Let's see, there's 10, 11, 12, 13, 14, 15. 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe going out to 20 on each one seems pretty reasonable. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Great. So the first inequality that we had was y equals negative, or sorry, y is greater than or equal to negative 1/2 x plus 10. So let me go where 10 is. My scale again is 1 box is 1 unit, so I'll go down 1 to the right 2. I'll keep that pattern going. This is going to be a greater than or equal to graph. So because it's greater than or equal to, it will be a solid line. And really, because everything's in quadrant 1, I'm just going to leave it like that. I'm not going to put arrows on the end of it. It's greater than or equal to, so greater than means shade up. So we'll shade this line up. Let's talk about graphing the other one now. The other one is y is less than or equal to negative x plus 15. Now we're going to graph this one in green, I think. So from 15, we're going down 1 each time. Again, it's going to be another solid line. And this is a less than or equal to. So we shade this one down. OK, so there's my clearly defined double shaded region up in there. So now, what do we ask to do with that? So we need to find a combination of babysitting and tutoring that Sue can do, a combination of those hours. Well, that's going to be in our double shaded area. Let's go to our graph and take a look at our double shaded area. I'm going to draw the double shaded area in red just to kind of highlight the region where we're looking. So it looks like we want to go anywhere in there. Can we pick a point anywhere in there? How about this one right here? And that looks like it's the point 4, 9. So what does that mean? That means that a combination of babysitting and tutoring hours, if she does 4 hours of babysitting a week, and if she does 9 hours of tutoring a week, she will satisfy both of her conditions. She works less than 15 hours, which was one of her conditions, and she'll earn more than $100. So just like before, we shade in our graph, we find our shaded region, and we select a point from there. Let's try one more together. Take a moment, read through what this says, and let's see if we can write some inequalities. So x is time spent on math, y is time spent on global. Did you notice, though, that we have a 2-hour and a 30-minute time? Yuck. I think I might make the 2 hours 120 minutes. This way I'm dealing all in minutes, and I'm not dealing in like a half hour, a quarter hour. I think that might make it a little easier for us. So let's write some inequalities now. So first of all, it says you have up to 2 hours. Up to 2 hours, no more than 2 hours, to work on your global and your math homework. So what if we say that x plus y is less than or equal to 120? You have up to 2 hours to do your math and your global. You know that global is always at least 30 minutes of reading. Okay, so we always got to read for global. So we always need at least 30 minutes of reading for global. So I'm just going to write that inequality, that global is always greater than or equal to 30 minutes. Yeah, but there's a math test tomorrow, so you got to spend some more time on math. So another inequality then, to spend more time on math. Math is greater than global. Not just in the real world, but in this story here. The time spent on math is greater than the time spent on global. The x has to be greater than y. Or if you want to switch it the other way and say y is less than x, either of those is good. So 3 inequalities. The first one here, you have 2 hours to work on the math and the global. Global takes at least 30 minutes, but more time on math. There we go. Let's graph these. Oh yeah, we got to change this first one, right? So if we subtract x from both sides, we'll get that y is less than or equal to 120 minus x. Okay, so let's set up some scale. I know I got to go up to 120 minutes. At least I got to be a little bit more than that. So what if I go like every 15 minutes maybe? Let's say that's 15, 30, so that's 60, that's 90, that's 120, 150. That should be pretty good. So we'll go 30 minutes, 60, 90, 120, 150. Sounds good. So let's graph our first one, which was y is less than or equal to 120 minus x. So our slope is going to be a slope of -1. which since our scale on the x and y axis are the same, we're going up by 15 boxes or 15 units is one box. Graphically, it's a slope of -1. So we'll draw that part in. And again, we're going to be shading down because it's y is less than. We can spend up to that much time. So we got that region there for us. So that was this one here, 120 minus x, or negative x plus 120. The other one was that y was greater than or equal to 30. You need to spend at least 30 minutes. Well, that, that y is greater than 30 means that we have a horizontal line here at 30. Y is greater than 30. We graph a horizontal line, or a y equals a number line is just a horizontal line. And the third one we wanted to graph was that we're going to spend less time on global than math. Math takes more than global tonight. So y is less than x. Check out this one, how the slope is going to be 1 and the y-intercept is going to be 0. This comes up from the origin up this way. And its y is greater than x, so shade it up. Holy cow, we have a triple shaded region going on here, my friends. Here is where our solution is. I'm going to outline it in black. Anything in that region is considered a solution. So let's come up with an amount of time you can spend on homework. Well, what if we pick a point, kind of running out of colors, you know? We'll use a point in the black. What if we say we go to right here? It looks like that's the point. .30, 60.